I accidentally didn't record, so we're just going to have to see me talk about the answer. We want to design a finite state automaton that recognizes the language of all strings, yada yada yada, where it contains ABC as a substring and CBA as a substring. Well, that's really hard, right? But maybe an easier tactic is to build a machine that can deal with ABC as a substring first, and then CBA afterwards, and then build a separate machine that does CBA first and then ABC afterwards, and then I can epsilon transition to either machine and then epsilon transition to a final state, right? Because if I've got a machine for A and a machine for B, the machine for A or B is this sort of epsilon NFA here, right? So here's my machine for the first part. Read ABC or read CBA. Here's how it works. You epsilon transition to this state. You read whatever junk you want. Read A followed by B followed by C. Read whatever junk you want, and then read C followed by B followed by A. And once you're in the final state, you stay there forever. Now this extra edge here I had to insert because of this weird funny edge case. If the C is shared by ABC and also by CBA, it's got the same C for both, which means I could also go A, B, and then skip the middle C, B, A. So I have to have this transition here, otherwise this string doesn't get accepted. And this string has both ABC and CBA as a substring in that order. So now I'm going to build a machine that does CBA first and then ABC second, which is basically the same machine again, but you do it backwards, right? So you read the CBA and then you read the ABC, and optionally the A can skip over the middle if they share it, right? So the string CBABC, the A is shared both by the CBA and by the ABC. So you would go epsilon transition CBABC. So we basically took the tricky problem and split it into two easier parts. So it's either this or that. Build a machine for this, build a machine for that, and then epsilon transition to either machine. Cool. Question B. Is your finite state automaton deterministic or non-deterministic? I guess it has non-determinism because I can do the epsilon transition, but strictly speaking, this is not a non-deterministic finite automaton because it's got epsilon transitions. This is an epsilon NFA. So I guess the technically correct answer would be neither. It's an epsilon NFA as it has as got epsilon transitions from S0, right? So that makes it not a DFA and not a NFA. Okay, cool. Let's move on.